Hello, if you're watching this video, I hope that you have reviewed the acid and base neutralization reactions that are on D2L. I have also sent out a link for those. And for these calculations, we do have some acid-base reactions. So of course, those are neutralization reactions. But in these reactions, you can't use our standard M1V1 equals M2V2, where you could make the ones be for the acids and the twos be for the bases. Well, you can't use that because these acid-base reactions don't have a one-to-one ratio. So there's several things that we could take a look at with these acid-base reactions, which we'll do in this video as you're reviewing. If you haven't worked these problems out, I would encourage you to get out your periodic table, your calculator, paper and pencil, and work these problems as we're doing this. And this will be a pretty quick video. All right, so here is your first neutralization reaction. If you have not worked this reaction out yet, I would encourage you to pause the video and do that. All right, so when you're presented with a problem like this, what's the first thing you need to do? Well, hopefully you're thinking, oh, I need to write this reaction, and you are exactly right. And so hopefully you remember the formula for sulfuric acid. I'm hoping that you remember that that is H2SO4. Oh, and that won't let me write that because it is sulfuric acid. And so your balanced equation is going to look something like this, because that's the first thing that you're going to need to start with. Now notice that I've drawn this arrow in just the forward direction. It is true that we could look at the equilibrium for this reaction, but because NaOH is a strong base and H2SO4, sulfuric acid, is a strong acid, they're going to they're going to have a big Ka value, so they're primarily going to form products here. And so we could write the equilibrium expression. If we were going to write that, we would put Na2SO4 over the concentration of H2SO4 and NaOH squared, because there are 2 moles of NaOH, so we could take a look at that. We could take a look at this salt, which is going to be a neutral salt from this reaction. But in this video, we're not going to do that. If you need other practice on that, kindly take a look at D2L or let me know and I will send you something. And so how do we attack this problem? Well, the first thing I always have to do is I've got to take a look up here and figure out, okay, so I've got 47 milliliters of NaOH. So this is my base. And I've got a concentration of 0.1 molar of my base. And those two go together. Then I have a concentration of I have a volume of my acid, but I don't have the concentration. So I'm going to try to figure out this concentration. And so for me, the first thing I always have to do is kind of match those up, because otherwise it's easy to get confused. All right, and so as we're taking a look at that, I'm going to start with the base here because I have 2 values for the base and only 1 for the acid, and I'm trying to figure out the acid. All right, and so another thing that I kind of always do is I remember that my molarity equals my number of moles, which is N, divided by my volume in liters. And so a lot of times I just kind of write that out so that I can remember all of those things as I'm going through. All right. And so I'm going to take my liters of NaOH and my concentration of NaOH, which remember is moles, big M is equal to moles per liters. Notice that here my liters of NaOH are going to cancel out. And now I'm going to look at my balanced equation. I'm going to see that 2 moles of NaOH equals 1 mole of H2SO4. And so now I've got my moles of NaOH. They're going to cancel out. And now I have moles of H2SO4. So I don't yet have my concentration, but I do know, because I'd written it out earlier, I do remember that the number of moles, or the big molarity, is my number of moles divided by my volume in liters. And I have this volume right here in milliliters, so I'm just going to have to convert that to liters. So that's going to be 0.025 liters. And so all I'm going to do then is take that molarity that the number of moles I've calculated and divide that by my volume in liters to get my molarity. And that is all I got to do. Then I'm just going to kind of multiply across there. And now that I have my moles of H2SO4 divided by my liters of H2SO4, I have my molarity of my H2SO4. So I found the concentration of that acid. Well, I hope that helps you. I've got another problem, though, for you. Of course, problem 2. So great time to pause the video and see if you can now go through all the steps. So what are the steps? Write my balanced equation. Take a look at which volume and concentration go together. Is it the acid or the base? And then figure out how many moles of that one chemical you have. Use your balanced equation for your mole ratio. And then take your, remember molarity is your number of moles divided by liters, and then work that out. All right, how did you do? So here was my balanced equation. Like I said, once again, we could look at, we know NaOH is our base. And so Na3PO4 is our conjugate acid. Is our conjugate base, also our salt. And H3PO4 is our acid. And water here is our conjugate acid. All right, so, but how did you do on the problem? Once again, did you take a look at these and match these up? And take a look. So this is my acid. This is my base. So I'm looking for a volume of my base, which I'm going to calculate in liters. And I have 2 values for my acids here. So that's what I'm going to use to get started, as you can tell. So I started with my base. I did my molarity, which of course is, whoops, let me go back one, which is of course the moles per liter. So if big M is my moles per liter, you can see that my liters of H3PO4 cancel out. Now my moles of H3PO4 cancel out. And I've got moles of NaOH. And I know that if I take my number of moles of NaOH, which I have here at the end, if I divide that by my molarity, big M, number of moles divided by molarity, that's going to give me my volume. And so there is my volume in liters, and then of course converted to milliliters, and to 3 significant figures. So this is how you'll go about working these acid-base reactions where there's not a 1-to-1 ratio. I hope this video has helped you as you're preparing for your Unit 4 test. Have a great day.